Welcome back to the series on using Python to trade through Metatrader. As promised, today I'm looking at backtesting, and it's not a simple topic. So I'm going to be taking this in several stages. And so this is the first part of showing how you can backtest your Python written trading robots that trade through Metatrader. Now, just before I start with the code, I've already created a folder here called Backtesting Part 1, and I've created a file in there called backtesting1.py, and that's just a copy of the old changing config. I'm going to be editing this quite heavily soon. Remember that the Python interface to Metatrader is an interface to the broker side API, so you can execute trades through the broker. Backtesting in Metatrader is done on the client, so Python has no direct access to the Metatrader backtesting engine. The Metatrader backtesting engine is actually a trade simulator. It pretends to be the broker's server. So when you write your code, that same code can be used in a live environment to actually trade or against the backtester. Because you can't use that Metatrader client function from Python, we have to use other libraries to perform backtesting. There are several packages available for Python that will allow you to do backtesting. They are all, at least all that I've found so far, oriented towards testing your strategy rather than testing the trade execution. It's a subtle difference, but I would like to have a package that lets me write the code once, run it as a test, see that the strategy works, and then simply run the same code against a live environment. Because if I have to write the code twice, there's always a chance there's a difference between the two and something will go wrong. Anyway, I'm working with what we have. So in this first part, I'm going right back to the basics of the backtesting, the way it's normally done through this particular Python package, which is simply to test that the strategy works. And I'm still using the moving average cross strategy, which I know isn't a good strategy, but it's good for demonstrating this kind of work. As I said, I've created this backtesting_1.py, and it is exactly the same as the changing config.py. For the purpose of running backtesting, I'm going to remove all of the work related to multiple configurations and even a configuration file. I'm going to embed everything back in the code here to begin with. So I don't need to import time or JSON or OS or types from simple namespace. I don't need the configuration file, and I don't need a default cycle time because the backtesting engine will take care of cycling through the trades. Or rather, the backtesting engine will take care of cycling through the events. I need to add an import for the backtesting engine. Here it is. From backtesting, I'm importing backtest. There are multiple classes inside backtesting, and you can see this highlight here. It says that I don't have that package available yet, so let me go to the terminal. So now I've installed the backtesting package. The error messages or the error highlighting has gone there. I simply installed it with this pip install backtesting. Backtesting works by me creating a class that is basically a strategy class. So I'm going to create the file for that now, and I'm going to put it in a subfolder of this backtesting part 1. So in classes here, I've created this file simple_strategy.py. I need some imports in here. And this is also importing from backtesting. It's importing the strategy class because that is the parent class of the class that I'm about to create. So this is the beginnings of the class. I haven't written any code here yet except this pass statement, so that I can simply have these functions here. And these are the two functions that I need to create to make this backtesting strategy work. There is the init function, and this is different to the constructor for a class, the _init. This is actually an init function that is called by this parent class strategy. And then a next, which is effectively what is called on every tick, or in the case of a backtest, every new data instance. But now that I at least have the shell of this, I can go back and finish the work on this backtesting1.py. It won't work until I finish more code inside Simple Strategy, but I'll finish this first. And I do need to import this Simple Strategy, so from classes, that's the subfolder here, .simple_strategy, that's the file name, import Simple Strategy, which is the name of the class here. Now I'm going to significantly change the structure here because at this stage I'm not simulating trading, I'm just testing the strategy. So I'm removing some of the structure, I'm putting this if not MT5 initialize right up here in main. Now to run a backtest I need a data set. If you run Metatrader you'll notice that it downloads history to begin with. There are a lot of different sources you can use to get history. You can even get the history from Metatrader. I'm keeping it very simple for this demonstration, and I'm actually using this mt5.copy rates from pos to get the simple open, high, low, close data for a number of candles. So I've got a history object that I'm creating, and I'm using the PD, that's the pandas.data frame, so coming back as a data frame. I'm using mt5.copy rates from pos, and I'm just hard coding. I'm doing Euro USD. I'm using the 1 hour time frame beginning at bar number 0 for 1000 bars. So 1000 hours of history I'm downloading here as a data frame. The history here includes a column called time, and time is in a Metatrader format, which is number of seconds since 1st of January 1970. I need to convert that to a date time. I can do that with the PD to date time function. And I'm passing in the history time column. I'm saying that the unit in that column is seconds, unit equals S, and I'm putting that back into the history time column. So I'm just converting that entire column. And then I want to make sure that is the index for this particular data frame. So history.setIndex, the time column, in place equals true, says that I'm changing it inside this history object. And then also the columns that have come back from this call to copy rates from pos are all lowercase, but this particular backtest and the strategy class expect these to be mixed case. So I need to convert all the column names from open to open with a capital O, for example. So I'm converting open, high, low, close, and tick volume I'm converting to volume because those are the names that it expects. And this also has the in place equals true argument. I'm printing the history here just so you can see something. It will print the first few rows and the last few rows so that we can see what we have. So the next step once I have that history is actually to invoke the backtester. So my test object equals backtest, and I'm passing in the objects which are the history, the data history, the name of my class. So this is not an instance of the Simple Strategy class, this is the name of the class. The backtester will take care of creating an object of that type. My starting balance 10,000. I'm running this as a hedging account, and finalized trades equals true means that when I reach the end of the test, any open trades are automatically closed. The same thing that happens in the Metatrader backtester. There are more arguments to this, but these are all that I need for now. Once I have that test object, all I perform then is test.run, and I'm capturing the results from that in this result, and then I can just print result to see what happened in the test. And I don't need any of the rest of that code in main. I will leave this log here because that is called here and here. That's just a minor thing. So that's much smaller now, and most of the work is going to happen inside the simple strategy.py. So now in the simple strategy.py, because I'm using this at the moment just to test the moving average crossover strategy and I'm not trying to simulate actual trading, I can perform some calculations once only in bulk at the beginning. So I can calculate all of the moving averages for every row ahead of time rather than do them as each row is appearing. So I do that in the init. I'm creating a variable called fast_ma. It's a variable inside the class. So self is the object or the instance of this class. Self.fastma, I'm assigning that. Self.I, I is an inherited function from the parent strategy, and it says this is an indicator that we're adding. SMA, that's a function that I'll write in just a moment. I'm using the close values from self.data. So data is that history data that we passed into the backtest. And then I'm using self.fastMA period and self.slowMA period. I'm going to actually define these two inside the class because I'm not using a config, so I'm just defining them. So I've just defined those two. I could easily have written 10 and 20 here. I just like to put constants somewhere in the code rather than have them embedded throughout. Now, this SMA function, if you remember back to the code we've had before, I actually have a function that calculates the moving average. There's a much easier way to do that. I'm going to add another import here. And that's pandas TA, it's technical analysis. So that gives me access to a lot of technical analysis functions. And I can see here that I don't have that package yet. So there, pip install pandas underscore TA, close that now. So there is a function in TA that is the simple moving average. It doesn't return the data type that I need here. So I've just written this as SMA. I'm now going to create a function called SMA, which is a wrapper around the ta.sma. And there it is, a very simple function. It simply takes a data set and the moving average period, and then it calls the ta.sma. So that's from TA here, SMA, passing in a PD series. So I'm converting this data to a pandas series with length equal to period. So that's setting the length argument for this SMA function. And then at the end, I'm converting that to a numpy or numpy, depends how you want to say it. And because that's the data type that I need returned. So after this, I've created a fast MA and a slow MA data series, all by calling this self.I, the indicator, for the simple moving average, which gets processed against all of the data.close using the fast and the slow periods. The next function is a function that's called by the backtester, and it's inherited from strategy, from this strategy. And this is where I process each pricing event. So I've only got the open, high, low, close for each candle, so I'm only going to get one candle at a time. It's going to call this, and it's going to call this next function. So I'm checking for a crossover, and this is almost the same code that I had before in my moving average cross, but instead of just a fast MA being calculated here, I'm pulling it from self.fastMA. This is almost the same code that I've had before in processing the moving average cross. Remember that the bar -1 is the current bar, and -2 is the bar before that. So I'm simply saying if the fast is below the slow, and on the bar before, the fast was above the slow, then I have a crossover. Actually got this backwards, that should be greater than, but the fast has moved above the slow. At that point, if I've detected that crossover, I just want to buy. I'm calculating a stop loss price, which is the close price from the data. Now here is something else to remember from these backtests. The backtest is being called once for each row of history data that I have. It's effectively being called at the end of that bar. Now in real life you never know when you're at the end of a bar, you only know when you're at the beginning of the next bar. But for this backtest, it's being called at the end of that bar, and so that's what I'm looking at. So I'm saying the stop loss price is the close price for the current bar, -1, minus this stop loss amount. That's another constant that I'm about to create. And of course the take profit price is the same, close plus take profit amount. So let me just create those two. And one more thing, in the buy statement here I have size equals self.lot size. So I need to define that lot size, but then SL equals the stop loss price from here, and TP equals the take profit price from here. It will buy at the market price. So I've added the constants here. The lot size is 0.1, the stop loss amount 0.001, and obviously this is a valid amount for Euro USD. You may want to change this for something else. It's only to demonstrate how to do this. In real life I would probably be setting this as a number of points or something like that, but for today I'm just hard coding a stop loss amount and a take profit amount at 150 there. So that takes care of a cross where I'm buying, where the fast has moved above the slow. I'll just do the same thing for sell. Almost the same code for the sell as for the buy. I've just reversed these signs, less than here and greater than here. The stop loss price then is close price plus stop loss, and take profit is close minus. And then the statement here, self.sell, everything else is the same. That's almost everything I need. That will run, but remember that I also had conditions that said I will only have one trade open in one direction at a time. So I need to count the number of open trades. This is counting the trades. So number of open trades equals sum of 1. So I'm adding 1 for each trade in a list of trades. So self.trades is a list that the self object, which remember is a child of strategy. Self.trades if trade.isLong. So there is a property of the trade object in here that says that it's a long trade or a short trade. So this is going to give me a total of 1 for each of the trades that are long. I should only ever have 1 or 0, and that will assign that to open trades. And I'm just saying if open trades is greater than 0, then return. I don't need to go down here because I already know that it's a cross in the upward direction. There's no point in checking for a cross in the downward direction. So I just return and it exits this next function. And then I've done the same here for the short trades. If the crossover condition is met and the number of open trades is 0, then I'll carry on and execute this code. I think that's everything. Let's see if we can run this backtest. That gave me an error. Let's see if I can fix that. Looks like there's a package I need to fix. There's a little bit of a continuity break here. So as you would have seen, I ran this code and got this series of errors, or it's one error, but it just goes through the stack. When I ran the code on my test computer, everything was fine. When I ran it then on this demonstration computer, I get this error. The problem occurs because on my test computer I had an older version of NumPy. And on this demonstration computer, because I've previously just done pip install NumPy, I have the latest version. There is an incompatibility between, let me scroll this up, Pandas TA and the latest version of NumPy. Now if you simply install Pandas TA, it checks for a dependency with NumPy based on greater than or equal to a given version number. So at version 2.0, NumPy made a change. Here at version 2.0, the alias NAN in mixed case was removed and replaced with, or wasn't replaced with, but after that use lowercase NAN. Pandas underscore TA is still using this mixed case NAN. Let me go back. There is a development version of Pandas underscore TA, and this particular problem was reported as a bug, but some time ago and hasn't been released yet. I'm assuming that's because there are other things in the next development release that need to be fully tested before it can be released, because this is actually quite a small change, or at least it appears to be a small change. So I've got a situation where Pandas TA doesn't work with the latest version of NumPy. I could choose to remove NumPy and install an older version, but I don't like doing that because what if I have some other package that needs the features of a later version of NumPy? You should always be able to run the latest version, so that wasn't a good option for me. I could simply go in to Pandas underscore TA as it's installed here and edit the problem, and I'll just show you how to do that. If I just right click on here, and I'm using VS Code, go to definition, takes me to init.py, and at the bottom of this I have from Pandas TA core. I can go to definition on that, and here we have Pandas TA momentum. You can see that in the errors here, momentum. Go to the definition for momentum, and then finally I can go to Squeeze Pro. Right click, go to definition, and you see right here at the beginning, import mixed case NAN as npNAN. I could simply edit that. That will work as long as you never reinstall this version of Pandas underscore TA. So do that if you wish. I don't like doing that either because that's a third-party package, and I don't want to rely on creating something that may be overwritten next time I happen to do a reinstall. And the other thing I can do, as I've done for testing purposes, I've created my own fork of Pandas underscore TA. Here it is in Orchard Forex Tutorials, Pandas TA. And I make no claim that I'm contributing to the Pandas TA development or that I'm actually fixing any problems. This is a quick fix, it's a quick and dirty fix. I haven't done full testing at all. But if you want to, you can installed this version from Orchard Forex Tutorials. All I have done, if I go in here to pandas_TA, Momentum, Squeeze Pro, exactly where we were before, I've simply made this change, NAN. And that will work for this particular test. And if you want to install this, again, I've made very few changes. I probably should, if I just edit the README, if I get around to that. You can install from GitHub. All you need to do is take this instruction, which if I get around to it, I'll modify, and replace that with Orchard Forex Tutorials, as you see here in the address bar. So you can use this installation to get this version. And I recommend, if you're going to do that, let me go back to VS Code. I've put some commands here that might be useful for you. You can use this command to install that repository, or to install a package from that repository if you like. But remember, this is not fully tested and you may run into all kinds of other problems by using it. But instead, for this demonstration, I have chosen, since it's only using a simple moving average, and I already had the simple moving average calculation written for earlier versions, I've chosen to just use that rather than rely on this pandas_TA. Going forward, I will want to find a resolution to this problem, because you will want a richer technical analysis library, and I disagree with having to have an older version of NumPy installed just for this, because it can create problems with other packages, as I said. So you may find some continuity issues in the rest of the video. Just keep all of that in mind. So now we'll just return to the original video. So where this would have been a neat way of importing a lot of technical analysis, I'm going to leave that for now. I have changed the SMA function to pd.series_data, that's the argument passed in, which is the close prices, .rolling window equals period, .mean. So that gives me the same result. It's a fairly simple calculation, so it's not hard to do it here. I will look into getting a better technical analysis library, or at least one that works in future, but this solves the problem for now, and then I just return result there. So now that I've done all of that, let's see if I can run backtesting1.py. Okay, so let's see what we've got here. This at the beginning is the history that I'm printing. So we can see there's the time, the open, high, low, close, volume, spread, which we don't use, and real volume, which also aren't used. And it's just printed the first and the last few rows from that set. I've run through the strategy. It tells me the first and the last. It tells me the duration was 60 days and 17 hours. It says down here somewhere I made 52 trades. And where is it? The final equity 9998.4575. So a small loss there. I didn't say that this was a good strategy, it's just an example of how to write this code. That's most of what you need. I'm just going to add one more little thing just because it's interesting. Again, if I go to simple strategy, remember that the result showed me the total number of trades. If I want to know something else, and I'm going to say, for the sake of the demonstration, that I want to know how many long trades and how many short trades there were. First, I'm going to create some class variables. So long trades equals 0 and short trades equals 0. Then here, where I open a buy trade, I'm just going to add 1 to the count of long trades there. I'll add 1 to the count of short trades here. And then back here in backtesting, I'm getting this result. I want to print those two values. So I'm printing the overall result, and just after that I'm going to print bit. So I'm printing a formatted string, long count equals. Now, result is returned from the test, dot underscore strategy. Remember, this is just the class name, it's not the actual object. So inside result is the actual object that's been created, underscore strategy, and then I can simply refer to dot long underscore trades, and the same for dot short underscore trades. I'll run that. There are the results, and here's my long count, 27 long trades and 25 short trades. So that's it for today. I don't want to make this any longer and more complex, but what you can see is that this simply tests the strategy. It's not testing the execution of trades, and it's not suitable to then simply take this and say I'm going to plug it in and trade against Metatrader or any other particular API for a backend. What I want to do is modify this further so that I can write this the same way that I might write a trading robot, and I can just run it then in either test mode or live mode, and it will either execute live trades or it will run against the test data. And we'll get to that over at least one, probably several more sessions. If this has been useful, please click the like button, and then if you want to see the next video and more after that, click subscribe and click the bell icon and you'll be notified when I release new videos. Thank you for watching.